Okay, the computer is still working, so I returned. Just put on some clothes because it's cold and this yellow thing is making all kinds of sounds. So now I'm going to do the video of transfer correction, some things from the standards, some drawings, the idea why we do it, how we do it, what we connect, how we draw the lines, and but I will put some link into the how you do it with a machine, because we need to find the doing part, not the theory part. Okay, so I'll be doing a longer one, and in the end how to do the transfer correction in the machine, and then use it and test it on the metal pieces. Let's pause. Okay, now some information from the standard ISO 17640 11.4 transfer correction. If the differences are less or equal than 2 decibels, correction is not required. If the differences are greater than 2 but smaller than 12, smaller or equal to 12 decibels, they shall be compensated for. If transfer losses exceed 12 decibels, the reason we should check was wrong. Maybe clean the surface so it's smoother, or other problems. Maybe the metal is not the same that you use for the calibration and for work. You need to find the problem if it's more than 12. So from 2 to 12 we're working with transfer correction. I have a drawing for myself and I like it. What I have is this. That's the normal probe. We'll do later. That's the angle. Now the theory and the why we do it is that transfer from the block, calibration block, this one or this one, the surface is near perfect. It's not perfect, but for our discussion it's perfect. Okay, now when we work on the piece, it can be not shiny at all. It can be sandblasted. Okay, so we have a problem on this level for the sound to go through. Then we have a problem here because the surface is not perfect here. The reflection is lower. Then reflection is lower here. So the surface conditions are different. Another thing what is different is the metal that is in here and the metal that is in here. Because this one is done according to the standard, and this one is that what it needs to be done to be welded. Okay, so these are different metals. So the sound through the metal, because it's different metal, goes differently. That's the second problem, and we need to solve these problems. The surface conditions on both sides, one problem, and the metal inside is also different. That's why we need transfer correction, because when I calibrate the probe on the DAC block, it works differently when you go to your working environment. The thing with that is that when we have a curve, let's say a reference line or an evaluation line, okay, you don't know what is that line on your working metal. So it can be lower or it can be higher. Okay, that's what we'll be doing. Now, one of the problems I found is that we start working with a 8 millimeter thickness. I like to have a transfer correction of 8 millimeters thickness. How to do that? There is a problem because our calibration block, that big one is 2.5 and that one is 2.5 centimeters, and this one is 1250. Okay, so 1250 is not 8 times 2, because 8 times 2 is 16. So I won't get a transfer correction for 8. I'll show you how I do it. According to the standards, I will check them. You don't have to do so much, because according to the standards, I think you have to take 2 points. One reflection, V, and another. So according to the standard, what you have to do is take 1 point like this, and then double V, and that's enough for you. You will get some kind of, no, not this way. You will get this kind of, and then you just look at it and extend it. I'm doing some more work, but you don't have to do it every day. So you do it once and then you have a good thing to use. So I'll show you how I do it. Now, transfer correction is in this short notice and in this 3 pages of transfer correction. What it says is the probe's position on a DAC reference block first is V formation and then double V formation, and the gain settings required to bring the echoes to the same height on the screen are recorded. So what you have to do according to the standard, is V formation, double V formation on the DAC block, and then that's it. The problem with that I have is my DAC block is quite small, so if I do it with like 70-degree probes, it will go like this and I won't be able to make a double V formation. Okay, but the DAC block metal is, according to the standards, the same as the V1 block and the V2 block here and V1 block here. So I'll show you how I do that, and but what you have to do, the minimum, is this thing. Another thing that I remembered is you have to take 2 probes, exactly the same probes. What I mean exactly the same probes is that they need to be, the size of the transducer should be, if you take 8.9, then both of them should be 8.9. If you take 2 megahertz, then you take 2 megahertz, 2 probes. And the angle should be also the same. What it means, and then if you do the transfer correction with 2 megahertz probes, then transfer correction is good for all the probes that you use with 2 megahertz. But it doesn't work like that if you put a 4 megahertz probe on and start working. Okay, I don't know how big will be the difference if I do the 4 megahertz transfer correction and then work with a 2 megahertz probe. Maybe it's very small, but it depends also on the surface conditions, on the metal conditions, so it can be different. So according to the standard, you should do like that. What it means is we have these probes, and what it means is I have two 70s, a 60, a 45, and an 80. But these are different frequency. I will do transfer correction with 4 megahertz probes, okay, and that's 70. If in the ideal conditions I need to take 60-degree probe with 4 megahertz and work with it, then I need to take 45-degree probe with 4 megahertz, because the transfer correction is 4 megahertz, and work with it, okay? That's the ideal situation, and that's why you need to think how many probes of what kind, of what angles you should have. Another thing that I found is I did transfer correction with two 45s, but when you make a V formation with two 45s, the angle is very narrow and you cannot push them together, and that's a problem. That's why normally I do that with 60, because you cannot move them close enough to do the normal transfer correction with 45. So what I would recommend from my experience is do the transfer correction with 60-degree probes of the megahertz that you will be using most often. That's the size of the probe and all the numbers of the probe. That's how you should do that. I will draw on the paper what I will be doing, and then we start connecting. Now, what I will be doing to check the 8mm metal, I will be taking version 2 block, that is 12.5, and putting one probe here and one probe here. That will be 12.5. Because when I do work on 8mm, if doesn't matter, okay? Then what I will try to do is, maybe if I can fit on this V2 block, I will do a V formation. That will be 2.5, and I don't need to do that because I have a V1 block, and that's 2.5. So I will take the V1 block and do this. That's 2.5, so I won't be doing that. That's 2.5, 25, okay, 25, not 12.5, 25. Then on the V1 block, that's a big one, I can do this. Then I'll check how much I can do with because I have 70 here. If I can, I will do one more like this. I don't know now because it's 70 and it's far away. I will do as much as I can to record points, as much as I can, until I don't fit on the block. And then I will have this line for my transfer correction, okay? And then I'll do more lines till it's 12. I have 4, so I'll check 4 times 3, so it will be -3, -6, -9, and -12. Okay, yeah, that's the way it will be. DAC curve, and we will have a working graph for transfer correction. What I'm going to do now is put on the 70-degree probe settings. Then I will change the settings and connect two probes. I will not take the DAC. I will take the normal settings. Let's go to the big menu, restore, recall, dataset, enter. Of 70-degree probe, enter. Here you go, unfreeze. Now there is a dual, not dual, through. I will take through, and it's the receiver, and it's through. Now, so now what you need to have is 2 cables and 2 probes, and I will put the green cable into the first hole, and it will be transmitter, and so green is transmitter. Here we have a transmitter, green. The transmitter out of these ones will be this one without the number, so I will put it on the green here. Now the receiver is without the green, and I'll put it here. Here you go. We have a transmitter and a receiver now. What I will be doing is, here is the V2 block, and here is the line that has no hole in it. So what I will be doing, I will be putting the transmitter here and the receiver here, and I will put it on the table and try to find like this. I have a lot of lighting here now because the sun is shining and you cannot see anything. I have put it on my head. Maybe no, doesn't work. Doesn't matter. I will try to find the best position on the screen like this. Okay, I need to put some gel on this and on here, and let's see if we find something. Here you can see on the screen that there is a spike. I will leave it here and do the gain, put the gain down. Now I can move only one. Here is the, let's say, okay, I have no space there, so I will leave the yellow one there, and I will move the, okay, this one, and I need to push the gain down, and then here you can see that here is the top, because you cannot see, but you can imagine what I'm doing. I'm just pushing it further backward, and the place where the spike is the highest, that's where I will record the DAC, okay, point. So here it is. I will leave that like here, and the distance between them is 12.5. I'm going now to DAC up, and I want to record this. Here you go. The first one is done. This is the way I have done it. Now I will take this block and pause. Now that's a little bit difficult to show you, But the best place to work with this block is here is the hole and here is some line. So the longest line you can get is from here to the corner, like this. That's where I will be doing transfer correction, through this line, so nothing gets in the way. But now I'm doing this part, and the way I will do it is on the bottom. Yeah, you can do it this way. Take the probe, put some gel on it and stick it there. Now on the other side you take another probe, you put some gel on it and you put it on the other side, and then and the screen doesn't show anything. Okay, here I can see something. So it's not straight, it's not paper, it's all kinds of things, but here something appeared. Okay, it's quite far already. It's like, I don't know, not ideal, because it's 70. Okay, so that's not great. I need to find what? Nothing. There are also numbers there, so I'll do that on the end where there is no numbers, no nothing. Here and here. Let's try this. Maybe it's enough space for the 70 to do the transfer correction. 60 is better here. Okay, we have what we have. Here we go. Okay, it appeared. Okay, so now I need to find the highest place that I can find, and then I need to record it. And you have to put it straight so that each of them, okay, here, maybe is the place I want to record this second point. Now the V formation, just clean that and put the V1 block on the side. Maybe you can see something. I need to put it further here. Now what I do is I pause. Now what you do is you take the ruler. I had a metal ruler, but now I have this thing for €1. I will put it like here. So here is the hole and here is empty space. Okay, maybe like this. And you take the magnet and you put it there. Let's say here. And then you take the magnet and you put it here. And it doesn't move. Now you have a line. A straight line for your probes. And now I have a transmitter and receiver, so that's difficult for you to show, but I will do that the way I can. So here is the starting point. I will put my transmitter here. Now I will put this on and I will create a V formation. Okay, I want to push it further. Okay, there. Moves a bit. The magnet is not great. Here you go. And then I will move it a bit until I found something. Okay, here you go. And that's in the middle. So one V formation with 70 is already half of the block. So then I find the highest point, and it's somewhere here. And then what I do, I record it. Okay, we need a gate. Of course we need a gate. No measurement. Here you go. You have a gate. One more time. One more time, and it doesn't show very well. I liked the other way more. Okay, here. Come on. Here you go, here you go, here you go. Here. That's high enough for me. Okay. Record. Now I'll check if I can get another one because it's down there. It should be down there. So, and I need to increase the range here because that's already far enough. Okay. Range is going home. Increase the range to I don't know what. 300, let's say. The thickness. Okay, we can do the thickness. Go home. There, that is to the big menu. I will start talking in Lithuanian. I need sugar, I think. Okay, let's do 25. Enter. Go home. Here is the, okay, now we know where we are. And that, what we done is V formation. Up, up. That's not exactly I see, but good enough. Now, the second one I can do from the other side, but I don't want. The second one, if I can get, it will be on the fourth leg. Because it will be V and V, somewhere here. What else? Nothing. I'll try to find it. And it's at the end here. And yeah, it's going down. So it's here at the end. Okay, I can get that here. Oppa. Because I want to see that it's going up and it's going down. So, and not. Okay, that's nice. Here, that's the point I want to take. I'm happy with that. Let's do it here. Move the gate. There. Come on. It starts showing something. And record. Here you go. That's the line. I cannot do more because it's at the end and this one is also at the end, so no more. It's with a 70 you can manage double V on this block. Okay, but I cannot do that as it says on the standard with this one, because with a 70 it won't fit double V. No chance. That's why you should do that with the 60. Pause. What I need to do that is save the recording, save the points, then do more lines and save this graph. So save the recording, save the points is here. Right. Great, stored. What I do now is 7. Do more lines, 4 lines. I go to offsets 2. Maybe this way. Great. Now, that is from the other side. I don't care. So I will do that -3. Doesn't work. I will pause. What I have done is made out of them -3, -6, -9, -12. Not important that it's not in the right order. Now what I'm going to do is go back, increase the gain a bit so you can see what I have here. That's the graph that I have for transfer correction. And now I have done that, I want to save it. And I'm going to save it. Big menu. Files. Store. 70, okay, good enough. Enter, enter. And that will be no number because that's 2 probes. That will be transfer correction. DAC. So when I need to do transfer correction, I will take this, I will connect the probes and I will do transfer correction. And I'll show you now what we will see. Now what? Now check piece 1 and 2. What I have here is this piece that is sandblasted, not very nice, and that is the thickness is 8. Now what I have also is a nicer one, and the thickness is 12. So let's try this way. That's my working piece. I have a ruler. I have the magnets. I have the gel here. And I have this thing that is transmitter and receiver. And what I do is I push them together, and you should see something on the screen now because the phone is in my face. I want to see and something also. So now when I push them together, okay, that's small. When I try to okay, that's the highest point I can get. Okay, so on this surface, two surfaces, sanded ones and metal different. Okay, when you do this, you can see that one is talking, one is listening from the V formation, and you can see that if I put the gate, okay, I will find the top of the spike, but you already can see that the spike is between 3 and 6, so it will be like 5.5, something like that. Okay, that doesn't reach that line, so I need to put the gate back like this. I'm learning also. I can't remember things. Okay? Maybe increase. Okay? No, don't increase. And then I'll do that once again. And then what you do is you find out that if you find a defect near where you work from the probe, like, okay, 5 centimeters, okay? Then if I push it hard, okay, but don't push it hard. That's the working conditions, not like this, okay? You can get better signal, of course, but you don't work like that. You work like that. So your transfer correction that you put in the paper or before that in the machine is like here, -5, okay? -5 is the top, okay? So for this piece, the transfer correction for the first one is -5. Now let's check another thing. Let's go back and let's find out the double V formation here. Okay, that's further away, and I need to move the gate. So I know the number. And the number is also okay, if I don't push it, it's 4.4. Okay, well, it's 4.4, 4.5, okay? So further away, it's 4.5, okay? And I cannot check further because it's not enough place for me. Okay, so out of these ones, I'll show you later where to put it in, but if you work with this one, the transfer correction is minus whatever you want. Put -5, okay? That's different the further away. That's why I want to have a big graph with many points, and I can check here, 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 in many places. With 60 you can do that. With 45 you have a different problem. So with 60, that's the perfect probe I have found to do the transfer correction. Let's do another one. The second metal piece. Another thing that you can do when you work is you just put the ruler on and you have a working place. So you just put the gel on both sides, okay? Because you will be scanning that. And then you check one side and the other side, okay? That's 12. Thickness is 12. Okay, so now I'm trying to find the peak, okay? And then here it is, and I have a gate on it. Let's put this, and this will be moving. Okay, here. This one is smoother, okay? And if I want, I can reach like 0 here. Okay? So if I push the probe, okay, I can get even better, I think, if I want to push that one also. Okay? So let's try. Here. It's higher than the line, but it's 0. So that these conditions are the same as these conditions. Transfer correction is 0. Now I'm going back and I want to find another one. Okay, here is another one. And if I push it, maybe I also can get a 0, but maybe I should not. Okay, so here it's almost 0, so it's 0.3. Okay, here you can see that here. So on the other side, what you do is do the same here. It's minus, okay, it's 0 here, and then it's here, it's plus. Here you can see it got over there. Okay, so the sound in this block, in this metal block, goes better, faster, or better than in the calibration block. So your transfer correction should be like around 0 here, yeah, or maybe plus, if you want, here plus 3. Okay, so here, yeah, it can be 0. Let's say it's 0, but it's the same as the calibration block. Okay, so this is the way you do the transfer correction. Now I'll pause and show where you put it. Let's return to the first one. Let's see, we're working with this one. Okay, we have found -5 and 0 on the second one, but we're working with the 5 one, and now we want to find the defects. What we do is, should I save it, or I have already saved it? Yeah, so I have this saved. Okay, I will now switch to this probe for working conditions. I will take the DAC curve here. How I do is and go to the big menu. I will recall dataset. I will find 70-degree probe DAC. Enter. Now what I need to do is connect this thing to the machine. I am taking the green one out. I think it doesn't matter which one you use, so I'll take the green out and throw it here. Now this one is not useful. This one is not useful. I will clean later without your attention. And now I have a working piece that is welded somewhere here. And I have a transfer correction to put -5. That's frozen. Why is it still this thing? -14. I need here -14. That's not what I want. It doesn't show anything. Okay, let's go back. No, I don't want this thing. I need 383 DAC. This is what I want. Unfreeze. Now that's my working set. Okay, here I can see something not perfectly, and in that standard, this one, there is a 10 pages about what to do if you have this problem. Well, you have to make more charts, cut it into half and things like that. So there is a solution for that, but it's not simple NDT, and I won't show you here. Now transfer correction. I am checking the weld. Okay, I need to put in the thickness. It's 8. I'm going to the big one. I'm going to the thickness and I'm putting it 8 because I need to look at the legs where my indication is. Enter. Here are the legs. I will decrease the range because that's too much. I need, okay, 2 legs, so that's enough. I'm checking with 2 legs. Now I need transfer correction because it's -5. You can just work with it, and when you find something here, you just put the gate on the defect, and the defect is like here, the corner. You see that maybe there is a corner. There should be a corner on the metal piece. Okay, here it goes through the roof. I'm already tired. I have a break now. Gate, start gate, back. It will be somewhere here. I will find something here. And okay, here is, oh yeah, I know why, because it's not okay. You are checking, and here is a defect, and the defect amplitude is like -1. That needs to be is like -1. That needs to be cut because it's over -4. Now I need transfer correction. I'm going to DAC TC-G up, now plus or minus. I need to do it plus because it's too, the sound is too weak. Let's try that, because I need this to go up, not down. So if I make it plus, it should go okay. I need to make it +5. That's transfer correction. Okay, and my indication went through the roof because it's the corner. Okay, so here you go. Okay, that's the corner, and now with the transfer correction you can work. And where do you see it? Let's go home, and maybe you can see it somewhere, or maybe not. Nothing is shown. Okay, so you just have to remember it then and check, because now we have a transfer correction put into the system. And now if you find this indication that is 8 millimeters deep, that is at the bottom, that is 3.5 decibels plus over the line. Okay, and then you cut the metal because there is something in there that should not be there. Now I can try to find the, I have a problem, my phone stopped. Great, one of the phones died because no storage left, so I have 49 minutes. Okay, so I wanted 50 and I'm in that. So that's the transfer correction. Everything is done. Now the next video will be about working with this 70-degree probe and 60-degree probe and 45-degree probe, and how you check the defects in the example that I have. Great news, that's finished. Transfer correction is finished. Thank you.